Can you unmelt these cubes of ice? No, you cannot. Unless you reverse the arrow of time, of course, which is impossible, or is it? If particles A and B collide to form particles C and D, the reverse is also possible. Somehow reversing this makes sense, but reversing ice cubes melting seems highly improbable. Here we can see that physics allows the arrow of time to be reversed in the subatomic world, but not the real world as we perceive it. So, what went wrong? The psychological arrow of time is the direction of time we perceive in our own brains, and whatever violates that seems to violate our common sense. The psychological arrow of time always goes from past to future, and not vice versa. But according to physics, the casual arrow of time, or the ultimate arrow of time, might also be reversed, because there is no hint of the direction of time at all given in the calculations. This is where the second law of thermodynamics comes in. The second law of thermodynamics states that things cool down, unwind, get old, decay, and weather. In other words, the second law prefers increasing entropy. Entropy could be defined in two ways. It can be a measure of a tidiness in system or how messed up things are. The ice cube straight out of the ice tray had low entropy, which increased as the cubes melted and the water molecules dismantled. Entropy can also be the measure of the ability to do work. After you have finished your breakfast with your coffee, you feel energized. That's when you have low entropy, which increases as you use your energy throughout the day. Entropy will always increase. In other words, every order will become disordered, everything tidy will become messy. So, the second law of thermodynamics gives us an arrow of time that only goes towards increasing entropy. At the thermodynamic arrow, the quantum world or the subatomic world has a quantum measurement arrow. The quantum measurement arrow stays reversible as long as we don't try to examine the system and isolate it. However, when we try to probe it, a definite direction in time is chosen. Another way of describing increasing entropy is the loss of information. When we lose information, entropy increases. In the subatomic level, where the quantum measurement arrow is in action, if we try to observe the system, certain information is lost, increasing the entropy and thus making the thermodynamic arrow in action permanently. Another arrow of time is the matter-antimatter arrow. Antimatter is just like matter, except having quantities like opposite charge and annihilate when come in contact with each other, leaving pure energy. Certain experimentation has suggested that if we start off with equal antimatter and matter in the form of subatomic levels or kaons, then at a later time there should be fewer antimatter kaons than normal matter kaons. This gives us an arrow of time that points towards reducing antimatter. Time is something science hasn't been able to fully understand yet. However, we're definitely going to the right direction.